Hello, everyone. I know after the coffee break, it'll be fun. Yeah, no worries. And I will make it quite vivid. I stick to the 15 minutes I promised, although the topic is quite complex. If you listen in the morning, you found out there were lots of aspects that are really crucial. You heard about connectivity. You heard about how do I get to the data. We talked a lot about AI. AI requires quality data. We are not in the consumer area. We are in the business-to-business area, so the data must fit completely. Otherwise, automatic decisions are not liable with respect to legal obstacles. And for that reason, we have to tackle several problems on several levels. And what I'm talking about is an approach, a global approach, to address these topics based on standards. We addict ourselves to standards, so basically non-proprietary solutions. We would like to get rid of these lock-in effects that we had in the past, or in more easy words, when we started Industry 4.0 like 10 years ago, we thought we put a sensor in the cloud and then everything is solved. That did not happen to come, and that is what I'm talking about. The challenges we are facing have been addressed already this morning. They're on the very right side. Resilience, sustainability, and competitiveness of every country is a major challenge. Competitiveness, I would like to stick for a second. The elephant in the room is China. And you can't come without a gift, basically, when you negotiate at the table. We have to have something. Europe is innovation. Europe stands for innovation. Data space for industry is a European innovation. And we use federated principles, so not centralized principles. What does that mean? We want to foster competitiveness by not having one element where you have everything, identities, discovery, and the data. There's just one element where you manage identities and then the data goes peer-to-peer. And that is, I guess, increasing competitiveness and increasing economy, not having one element in the center that does it all. That is the innovation and the answer of Europe to the market. So I'm talking about industry here, on industrial and market offerings, and basically using all the things that you learned in the morning in these discussions. Resilience is clear. Sustainability changes more and more. It's more than greenhouse gas reporting. That is compliance. So basically, regulation needs to be satisfied, by the way, happening around the world. From US to China, you need to satisfy greenhouse gas regulatory rulings. However, these things change, and what we really foster here is that regulation is non-conformance cost. We would like to create business. We as industry need to earn money, and we have to prove that also in the digital domain. This International Manufacturing X Council was founded out of these reasons, and it really orchestrates, incorporates, as you see on the right side. We influence and lobby, and we define. And what we really influence on is standards. We want to have a very limited set of standards that apply around the world and can satisfy both the federated approach that I just talked about, as well as the central approach, but at least only one standard, so that products from Greece, from European countries, from the rest of the world, do not need to implement so many different software standards. Please have one set of standards, and the governance and the operation comes by the policies and rules that are loaded in. This is exactly the difference. But the core technologies, as limited as possible, hardened IEC standards with a clear life cycle, fully professional, not one IEEE standard after the other popping up to satisfy some stupid KPIs that you as an individual get by your employer. That doesn't help at all. We try to kill these IEEE activities as much as possible. Usually it works. For us, Greece is super important. Look at that SEV there. We had that wonderful, by Maggie, that wonderful presentation this morning. So it's a journey. 13 countries. Canada is basically the RCI labs. That's a network of smart factories, which I think fits super well to Canada. Mining is the core there. SESME was founded under President Obama. It's one of those 5 smart institutes that are not military funded, so DOE, not DOD. And then in Europe, we have certainly Germany with Industry 4.0, SEV in Greece, and some more. And then super important, Japan with RRI. RRI is the player for 14 years in the area of Industry 4.0, which really combines IT and OT with a lot of momentum and foundation in Japanese manufacturing. Cosmo in Korea, super relevant. China and India are not highlighted here. They are fully addressed, and later on you'll see they cooperate. However, we handle them differently. We handle them out of public. Several reasons, I mentioned those reasons already before. The developments in China are not coming at surprise, and all of a sudden, oh my God, what happened? If you look back on all the strategy papers for the past 20 years, it was clear to us, at least speaking on behalf of Siemens, I can say that we have that clearly on our radar. Nevertheless, the extra elements that came along, in particular the tariffs, speeded that up. So we need to change and adapt even more rapidly. What are the major outcomes of this International Manufacturing X Council? I spoke about the standards, very few standards, AAS, OPCOA for the semantic interoperability, EDC for the data connectivity, for the data connector for the data space, and that's it. And however, in the blue line, you see use cases. We were able to align on 15, 16 industrial use cases where we could prove that going into a data space and using this structured approach is cheaper, business-wise cheaper than using traditional or normal methods. Again, all those use cases are solved for the past 50 years. They are solved. Solutions, industry solutions are out. Nevertheless, we say with data space you can cut cost and gain better quality. This is the approach. Usually those are the use cases where you need to do cross-company, so cross-vendor, as well as cross-country data exchange. And let me briefly jump to some use cases that you see here, which we work on in the project Factory X in Germany. I come back to the slide before in a couple of seconds. All those are sorted along the life cycle. And in integrated tool chain, we really could prove that all the manual work, maintenance work to set up the digital twins, etc., are cheapened if we use data space. Circular economy is just a nightmare when you really make it specific. So after 10 years, parts of your machine return or components return, you have no clue what happened to them. If you have a digital twin, which is then maintained, you can seriously do circular economy, including the disassembly story that you can't do seriously in a cost-effective way with labor cost in Europe without this digital twin information maintained in a data space. Why data space? Because the data belongs to the factory operator in the past 10 years, then it goes back to the machine builder. That's already a legal transition, and then it goes back to the single element or component producer, the next legal transition, and there you must have clear rules, otherwise this data won't move. And the ideal point is in the future, and that's what we'll do also with Siemens, when you purchase certified products, these digital twins remain or stay at the producer site. So the updates over 20, 30, 40 years, and you know how long the life cycles in industry are stayed at the producer side. So the instance of each thing stays there as a digital twin on AAS server or comparable technology, and then you have serious quality data on this instance, on this object, and that is a very good base for AI applications later on. The other use cases are all relevant. What is the end goal really? It's really autonomous operation. We are fostering clear full stack autonomous factory and autonomous production. This is why we do all this extra effort with data space and we set up this infrastructure. It's basically an infrastructure project, right? Earning money with a data space in industry is pretty hard. We have one OPCO, it's Cofinity X in Cologne. They live and so on, but it's really hard. We set up a data infrastructure for industry to be then able to set up genetic and AI. And we are not alone there in Europe and in Germany, France is very active, Italy also. Davide from Engineer, I'm not sure if he's here today. Japan, ODS, the open data space. is closely working. You might look for Uranus there. Uranus stays political, and ODS is now the technical element. Other data space around the world. One comment on China, 100 data spaces, it's 99 plus 1. One will be Catena-X using the EDC technologies. And underneath, you see really these elements that you need to set up this industry infrastructure. It's really influence. You need governmental blessing, otherwise it doesn't work. If you want to really do federated data exchange, it includes the export, et cetera, you can't do it just company-wise. Otherwise, you're running in issues. Then build it, run it, operating and govern of a data space and industrial data is key to success. You need to operate the data under clear rules, reliable for decades, and then scaling. Let me come to kind of a summary now. Autonomous factory is our core. That's really the main goal, the main use case, the main vision. At the moment in Europe, roughly 60%, it's a standard 5-axis machine tool, I don't say from whom. Only 60% productivity usage. That's totally insufficient with these investments for machines that we are facing. Totally insufficient. We need to get here, and that only is possible if we really go to autonomy. And productivity was and is the key element of Europe. In the past 10 years, it decreased. That's the problem why we are there where we are at the moment. We need to look at our productivity here in Europe. We have a use case, a showcase. It's really physical, it's there. And it has two elements which really are seriously for us. Edge is where the AI will be computed. So the training and the model building happens in the cloud, but the execution is at the edge. Either at a production line or even per single machine, it depends on the process, etc. But it happens at the edge. So we need to make sure that the edge is managed such that that all these goals, trust, autonomy, and data sovereignty take place. That's extremely important. The second one is really compliance, regulatory, with a battery passport there. You see all the different countries, and why did we put them at the bottom? There's this support use case. And that is federated trust. That's really the base. Technical trust is the base. Without that, you do not share data. And trust means you can request data, and someone can say yes or no. By that, you are sovereign, and you only trust, let's say, Siemens or BMW or Ingeniera or whoever, if this is ensured and maintained over decades. This is key to success. For the battery passport, these are 5 major car OEMs from the US and Japan and Germany, France. And for the edge, it's really the key producers for PLCs and edge devices around the world. We really take it serious. So the servers where these data lies on are combined in this demonstrator and worked out. Again, as a summary, we have that famous triangle being discussed today very often of infrastructure, data, and foundational models to make physical AI or AI, generative AI, for industry possible. Physical AI will be a key application area for that. Not humanoid. We will not see humanoid. I guess we will very little see humanoid robots in factories. We need to go really towards autonomous production. It doesn't matter if it's in humanoid robot or not. It's really that the autonomy is taken care of, that the processes are flexible, combined, and this can be much better modeled with AI. A short look at Europe. I took out the READY project being running in these European digital innovation hubs. We have the wonderful TEF by Sergio in Milan as one example. We should look for in industrial data spaces like this International Manufacturing X as an example. Smartness, Data for Space, projects of European Union are good leading roles. They produce radars and give overview. So if you need more information there and what's going on, these are good addresses to look at. Thank you very much. And I skipped that. That's for details. Thank you very much. And I wish this conference all the best. Thank you very much for this wonderful invitation.
Thank you. Thank you for staying on time. We have time for one question from the audience.
Sure, with pleasure. I touched a lot of different topics. It's super complex.
Okay, it seems that we don't have any question. I have one question that I would like to ask you. From all these use cases that you showed us, which is the use case that surprised you the most, meaning that initially you expected less impact, but the results were more important?
Business-wise, circular economy. We found out that disassembling of components of machines or industrial products is much more, information is much more available than we expected. So we were thinking less and we were surprised. And I think this is something where Europe is really strong in. Mm-hmm. Put it this way, Asian automation technology is usually coated, the PCBs are coated and the devices are glued. In Europe, usually screws are used and not coated. And even military devices like condensers or resistors. And all of a sudden it makes sense business-wise to repair, remanufacture or refurbish. And all of a sudden there's really business with a double-digit percentage EBIT possible. Okay. And data space helps us to get the data in an anonymized way, but in a structured way, controlled way. So that surprised me. Money is earned there, as one example. The other one is traceability.
Very important to see that from circular economy is also linked to business also benefits from the industrial operations.
We don't believe that the throwing away linear economy has a future, and that's totally independent of political discussions. So it's a business decision that it makes for high-end components of machines or certain products a lot of sense to take them back and reuse them in a useful way.
Okay. Thank you very much. Thank you for your answer.